Hello! In this video, we are going to prove the following theorem. Suppose A and B are sets. Then, A intersect B is equal to A if and only if A is a subset of B. So really, we're trying to prove a statement containing if and only if. Which means, what we can do is we can prove that if this is true, then this is true. And if this is true, then this is true. Let's start out by proving if this is true, then this is true. To do so, let's assume this is true. And our whole goal now is to deduce that this is true. So we're trying to prove that A is a subset of B, which means we want to prove that everything in A is also in B. And to do that, give me an arbitrary element in A. I'll call it X. And now we want to prove that X is also an element of B. And to start, because A intersect B is equal to A, what that means is these two sets have the same exact elements in them. So, because X is an element of A, that means X is an element of A intersect B. What does it mean to be an element of an intersection? Well, it means that X is an element of A and X is an element of B. So one of the things that we get from it is that X is an element of B. So notice, we started with an arbitrary element in A, and we showed that same element is also in B. So because X was an arbitrary element of A, this means every element in A is also in B. So that means we've proven that A is a subset of B. So we started by assuming that A intersect B is equal to A, and we deduced that A is a subset of B. So really, we have proven that if this is true, then this is true. Now we're going to prove that if this is true, then this is true. And to do so, assume this is true. And our whole goal now is to prove that A intersect B is equal to A. And we're trying to prove that two sets are equal. To do that, what we can do is we can show that everything in this set is also in this set, and everything in this set is also in this set. Let's start by showing that everything in this set is also in this set. So really, to do that, we're going to be using the same strategy that we used in part 1, right? We're going to take some arbitrary element in A intersect B, call it X. And now we're going to deduce that X is also an element of A. Well, because X is an element of A intersect B, we know that this means that X is an element of A and X is an element of B. So one of the things that we get from this is that X is an element of A. So we started with an arbitrary element of A intersect B, and we showed that same element is also in A. So since X was arbitrary, we have shown that everything in A intersect B is also in A. So now that we've shown everything in this set is also in this set, now we have to show that everything in this set is also in this set. So to do that, give me an arbitrary element of A. I'll call it X. Now, because A is a subset of B, we know that this means that everything in A is also in B. So, since X is an element of A, that means X is also an element of B. So notice, we have that X is an element of A and X is an element of B. That is equivalent to saying that X is an element of A intersect B. So notice, we started with an arbitrary element of A, and we showed that same element is also in A intersect B. Since X was arbitrary, that means everything in A is also in A intersect B. So we have shown that A intersect B is a subset of A, and A is a subset of A intersect B. These two facts together amount to saying that the two sets are equal. And so now, notice we started by assuming that A is a subset of B, and we deduced that A intersect B is equal to A. So really, we have now proven that if this is true, then this is true. And so we have proven both parts of the if and only if, which means we have proven this statement. And so this completes the proof. So yeah, that's pretty much the idea of how you could prove a statement like this. And yeah, that's pretty much it for this video.